this next thing is called linear programming, and it's a little complicated in that there are a lot of equations and there's usually like 3 to 4 inequalities that you have to graph, and what you have to do is figure out based on the graph, you can figure out something called the something called the objective function, which is what you're going to use to maximize either the profit or the volume or the area. You're trying to maximize something, and this was actually used. It's actually used in manufacturing, and it was used extensively. The guys who developed it were the bad guys. What's that little blue thing? I don't know. It was developed by the bad guys during World War II, the Nazis, because they used it to make tanks, and they figured out if I have so many hours it takes me so many hours to do this, and it takes me so many hours to build a tank, and so many hours it costs this much, and so many hours to build parts for the tank. They use this process called linear programming to figure out how to best allocate their time or their resources and stuff like that. So let me kind of take you through this. And I guess nowadays it's used like in the manufacturing industry, like in the auto industry and stuff like that. So Monarch Marching Man is selling tacos and burritos to make money for a trip to Washington, D.C. You really have to read the whole problem. To make enough money to afford the trip, I don't know what this little blue thing is doing there. I don't know how to get rid of it. The club must sell at least 10 burritos and 30 tacos each day. Because of limited space, no more than 40 burritos or 70 tacos can be made. The total number of orders cannot exceed 90. If the profit is $1.65 per burrito and $1.05 per taco, how many of each item should the club sell in order to maximize the profit? Okay? Well, your first task should be to assign some variables. So the first variable that I would assign is let t equal what? No, I wouldn't let t equal I would let t equal tacos. That would make more sense to me. I know you're just kidding around. Okay? And so b equals, and that's the number of, that'd be number of palitos. Okay? And then we're going to try to translate. What you have is a bunch of constraints. Okay? Translate at least 10 more burritos and no more than 40 burritos. How could I write that as an inequality? Katira.
Greater than or equal to 10.
Perfect.
X.
Greater than or equal to 10 and
1.65.
less than or equal, no 1.65. Now, you got to have no more.
Equal to 40.
40. Okay? That's how you would translate it. There's at least 10 burritos and no more than 40 burritos, right? Yes? No? Okay. Translate at least 30 tacos and no more than 70 tacos. That should be easy, right? And once we did this, can I just do that? 30 and less than or equal to 70? Yes? Easy enough? Are we done? No. Now we have to find another, I'm down at the bottom of the page. So now, do you got that down? Because I'm going to move on to the next part. What's wrong? You're just stretching? Okay. So now, I'm going to go back down to here. Translate, who can tell me how to translate the number of orders cannot exceed 90 into an inequality statement? Go ahead, Amanda.
X is less than or equal
Not X.
Oh, no.
Altogether, what do you have?
T plus E.
T plus B. So you have tacos and burritos, right? And those have to be less than or equal to 90. You understand that? Right? And then write an equation to represent the profit. Well, if you go back, I can't go back, but I profit is $1.65 per burrito and $1.05 per taco. And so I want to write an equation for the profit. So the profit is going to be, how much was it? What does it say in your paper? I'm sorry. Oh, I got it right here. 1.65 per taco. And, oh no, that's wrong. Per burrito, sorry. Per burrito. And plus 105 per taco. Okay? And this equation is called, whoops, T. And this equation is called the objective function because that's the thing that you're trying to maximize. Okay? Now, the next step when you're doing one of these is to graph all of your inequalities. Okay? So, and then what you do with your optimization equation is this doesn't get graphed. What you do is you plug in, I'll show you what you do. Okay, so let's go back to the graph. I'm going to get the graph up here. I'm going to see if I could take this. Let's see. I'm going to take a picture of this so that I can put it on the big screen. Okay. So the first inequality was that B is, I'm going to write them all over here. Okay. B is less than or greater than or equal to 10 and less than or equal to 40. Okay? And I'm going to, we already did it for you. Okay? So you have burritos down here, tacos over here. So less than or equal to 10, what kind of line is that going to be? It's going to be a solid line. And if this is burritos down here, what does that solid line look like? Is it going this way? Is it going this way? If this is burritos, Jessica, it's a vertical line at 10. So you're going to put one vertical line at 10, okay, which is going to be, let's get rid of the, well, we could put arrows on both ends. So a vertical line at 10, going from here to here, okay? And then, and we don't really have to worry about negative values because you're not going to have negative tacos or negative burritos. And then you have a vertical line also at 40, like this. Okay? And I'll show you what we're going to do with this in a minute. The next constraint was that T, hey, Akash is here. T is greater than or equal to 30 and less than or equal to 70. Miss Deb left because you weren't here. So you want to go find her? Okay, it's okay. So I'm going to write T, and T goes this way, right? So T is less than or equal to 30. So what kind of line is that? Vertical or horizontal? If this is the T, this is a horizontal axis, okay? So I'm going to put T goes straight across here at 30 and another one here at 70. So far, so good? And the final constraint that I'm going to graph is that B plus T is less than or equal to 90. So in order to graph this little one, I'm just going to put, I'm going to make B 0. When B is 0, what's T? 90. And when T is 0, what's B? 90, right? So I have 2 points on my graph, one at 0, 90, and one at 90, 0, and then I'm going to connect those two, okay, with a line. And you should really use a ruler for this. And I'm not going to, you could just try to do it as best as you can. Use a side of your paper or something like that. Now, this area right in here, okay, whoops, right in here. So this is greater than or equal to 10 and less than or equal to 40. greater than or equal to 30, less than or equal to 70, and then b plus t is less than 90 is actually going to be below this line. Okay? And what the bad guys figured out during World War II is that the objective function, this 1.65 b plus 1.05 t equals p, what they found is that the maximum or the minimum is always going to be found at one of the points that is at a vertex. So what you do you understand what I'm saying? Okay? So if this is the region in here that's greater than this, less than this, greater than this, less than this, and less than this line. If I find the border points of this region, you should actually use this one too. If I find all the vertices, you guys know what a vertex is, right? See this shape? This shape makes what's that called? Anyone know what that's called? Trapezoid, okay? So what they found is that the maximum and the minimum of this function is always going to be found at one of those points, right? So the way you do that, the way you figure out where the maximum profit is going to occur is by plugging in all of these points into this equation, okay? So the first point I'm going to plug in, I'm not even going to plug in this point because I know that this point is going to be lower than this point. You understand that? Right? I'm not going to worry about this because if I plug in 10, this is the point 10 comma 30, that's going to give me a lower value than this point, which is the first one which I'm going to plug in, which is 10 comma 70. Okay? This point is the next one I'm going to plug in, which is 20 comma 70, right? 20 comma 70. The next point I'm going to plug in is this one right here, which is, what's that? 40 comma 50, right? And the next point I'm going to plug in is this one down here, which is 40 comma 30, okay? Which probably you don't even have to plug in. I probably don't even have to plug in this one and this one, or excuse me, this one and this one, but I'm going to do it anyway, okay? So 10 comma 70, if I plug it in here, is going to give me $1.65 times 10, right? Plus 105, that's not very good, 105 times 70. And if I do that, that comes out to be $90. $90. All right? If I plug in 2070, anyone tell me what I get out if I plug in 2070? It's going to be $106.50. If I plug in 4050, okay, let's just do it. 4050, I get 1.65 times 40 plus 105 times 50. If you do the math, you end up getting $118.50. And then I'm going to plug in this point, 40 comma 30, which gives you out less than this, right? Because I have 20 less tacos than I have burritos, so obviously it's going to give you less, but still you should plug it in, and in that case you get 97.50. Okay? Which point maximizes the profit? This one right here. Okay? So to answer the question, I should sell 40 burritos, 40 comma 50. I should sell 40 burritos and 50 tacos. You see the way that works? It's kind of tricky though, setting up all the inequality. Kind of tricky. That's not a very straight line. You should use it straight up. Anyway. Okay, but we're going to do another one because They're all a little different and they're all a little hard. Now, sometimes they want to minimize something, like minimize the cost or minimize the expense, and that would probably be found at either this point or this point. So you got to really, depending on the question, you really need to plug in all the points, because sometimes you want to maximize something and sometimes you want to minimize it. So what you're doing, you're plugging in all the points in that. This thing has a name, at least when I've taught it before. It's called the feasible region. Okay? Feasible region. So, and any point in this area will work, but the maximum and minimum are going to occur at the vertices. We do another one? Yes, we should. We got it, because these take practice. And the hardest part is figuring out what your inequalities look like. So what's the next one? Is this the next one? No. Here's the next one. Uh-oh. Tomato plants. Roma tomato plants. And so let's read the question kind of first. Let's try to get all this stuff in one shot. So we have, it says Roma tomato plants cost $2 each and they're guaranteed to yield 8 pounds of tomatoes per plant. Cherry tomatoes cost $3 each and they're guaranteed to yield 10 pounds of tomatoes per plant. You want to spend no more than $40 for at most 15 tomato plants. How many of each plant should you buy to maximize the pounds of tomatoes you'll get? Okay, so what kind of tomatoes do we have? Cherry tomatoes and what other kind? Roma. So I'm gonna let R equal Roma tomatoes. What you want to, what pounds, right? How many of each plant? So I guess R is equal to the number of Roma tomatoes. I'm going to change that into a number sign. The number of Roma plants, and therefore cherry tomatoes, C, is equal to the number of cherry tomato plants. Who can give me one constraint? Can give me one constraint in this one? Go ahead, Jessica.
2R plus
Nice.
2C is less than or equal to 42.
Yes, ma'am.
Wouldn't it be,
That's one constraint.
can I do another?
Go ahead.
Wait, oh, okay, 8R plus 2. Is pounds of tomatoes 1 tomato per pound? Or is it like, because it says
Pounds
of
per
tomatoes, and
plant.
it says
That's how many
15
pounds you
tomato.
eat. But that's what you're trying to maximize, okay? You're trying to maximize the pounds, So that's going to go down here. You understand that? So what would that look like, Katira?
8R plus 10C.
8R plus 10C is equal to, we'll call it pounds. Do you guys understand that? Okay? Because you have to really look at what you're trying to maximize. How many of each type of plant should you buy to maximize the pounds of tomatoes you'll get? Okay? And so 10 pounds per cherry tomato, right? And 8 pounds per tomato plant. But does someone see another constraint that I could plug in there? Go ahead, Hannah.
R plus C is less than or equal to
Perfect. R plus C is less than or equal to 15. Okay? And even though it's not here, it's not explicitly stated, R has got to be greater than equal to 0. And C is also got to be greater than equal to 0 because you have to have at least 0. You can't have negative plant. All right? So this is now what I'm going to try to graph. Got it? Do you any questions about that? So, but it's tough because you have to sort through the information, and I always have had a hard time. So now we're going to take this, and I'm going to see if I could take this picture, and let's see, cancel. I'm going to go back. I'm going to go to my graph, and then I'm going to go back and copy that. Where am I? Tomatoes. And they didn't give you any nice scale or anything like that, but and then here's that. And then I'm going to see if I could go back and copy this. Make it small. Where'd it go? Where'd it go? Anyway. Oh well. We'll go back to where I was. Where was I? Ah! Go away. Let's go back. So so let me just write it. Okay? I've got r plus c less than or equal to 15. I've got 2r plus 3c less than or equal to 42. I got r bigger than or equal to 0 and c bigger than or equal to 0. Does it matter which axis I put on which? It doesn't really matter, okay? So I would just call this axis the Roma axis and this one the Cherry axis. And if you did it backwards from that, you should still get out the same answer, okay? So for this one, pretty quick, when r is 0, what's c for the top equation? 15. So I have a point when r is 0, let's maybe count by 5s. 5, 10, 15, 20. 5, 10, 15, 20. I would say that would work. 5, 10, 15, 20, 5, 10, 15, 20. And then, so when r is 0, c is 15. When c is 0, r is 15. So I'm going to draw a line between those 2 points. I'm going to make it I'm going to get rid of the arrows. I'm going to make it red so you can tell the difference. So there's 1. And it says less than, so I'm assuming it's going to be below this graph. Okay? Now let's look at this equation, this constraint equation. Let's make a little table. RC. When r is 0, what's c? 3 times what number gives you 42? 42 divided by 3. I'm waiting. 42 divided by 3. Come on. 14. Okay? When c is 0, what's r? 21. Okay, so now I have 2 points for my other equation. So r is 21. Let's call it like right over here. Not going to be perfect. And c is 14, which is right below here. And now I'm going to connect those 2 points. So it kind of looks like this. All right? R is greater than 0 is going to be just this line over here. Whoops. C is going to be greater than 0. It's just going to be this over here. So my feasible region in this case is going to be in this area right in there. See it? Okay. Well, the points that I have to plug in are this point, which I can figure out, this point, which I can figure out, this point, and probably this point as well, even though that's going to give me nothing, right? So probably I don't have to plug in 0, 0. How can I find this point right here? Because unless I graph really accurately, you have to do that algebraically, okay? So all I'm going to do is go r plus c, I'm going to go fast, equals 15. And I'm going to multiply this equation by -2, kind of what you did. because I need to find that point of intersection. So I get negative 2r minus 2c equals negative 30. I'm going to put this equation below that and add them together. You could use substitution too. 2r plus 3c equals 42. Add them together, those go away. I get c equals 12. If c equals 12, what's r? If c is 12, what's r got to be? 3, right? And so this point right here, even though, see my graph is kind of messed up, it's 3 comma 12. Okay? Now I plug in this point, not this point, I plug in the 3 points on the border. Okay, I should actually plug in all the points. So I'm going to plug in 0, 0, which is down here, which is going to give me nothing, right? I'm going to plug in 0, 14, which is this point, okay? And that one gives me 140, okay? I'm going to plug in 312, which is the point I just found. And if I plug in, I forgot to write my objective function, which is p equals 8r plus 10c. Okay? So I'm plugging into this equation when I do that. Okay? When I plug in 312, I get out 144. And when I plug in 15, 0, which is this point over here, I get out 120. Okay? How many cherry tomatoes and how many Roma tomatoes should I plant? I should plant 3 Romas, right? And 12 cherries. You get it? Okay? But they're tricky, all right? So beware, all right? So for homework, not that long, for 27 minutes, man. Where's Stella's farm go? Is that Stella's farm? There she is. Okay. So Stella's farm consists of 240 acres where she wants to plant pumpkins and squash. Let the profit per acre for pumpkin be 400. The profit per acre for squash be 300. The number of hours for labor is 3,200. Each acre requires 20 hours of labor. Each acre of squash requires 10 hours of labor. Determine how the land should be divided between in order to maximize the profit. So I think you guys, we could figure out, oh crap, where did it go? There it went. I'm going to take a picture of it. So let's just set up the constraints really quick. Well, let's set up the objective function. Objective function, well, first we have to do the variable. So what do we have? Pumpkins equal acres, right? It's acres, isn't it? The profit per acre. P equals acres of pumpkins. And S is equal to acres of squash. And objective function, you want a profit. How much do you make per pumpkin? Profits. You make $400 per pumpkin. And how much do you make per squash, per acre? 300. 300 per squash. Okay? Yes, ma'am. Go ahead. Give me one objective function. I mean one constraint. Sorry.
20p plus 10s equals 3,200.
20p plus 10s, very nice, is less than or equal to, right? Requires the available is got to be less than or equal to 3,200. Okay, how could I use this 240? Go ahead, Will.
S plus P plus 240.
Right, P plus S is got to be less than or equal to 240. Do I have another one in there? Each pumpkin, is that it? 240 acres, 40. I think that's it. You should also do P is greater than or equal to 0, and S is greater than or equal to 0. And then you should have you should have enough to go by and do that one, right? The one on the back side is a little bit more tricky. See if you could figure that out. And then try to do the Math Excel ones. You have 3 days to do it, because I won't see you guys again until Thursday, right? So, and that's it. And then we're having a test next on Friday. Thursday's going to be review day, and Friday we're having a test. I posted it on Schoology, so we're okay. And I'm pausing it.